Welcome to the CAD Office Training Guide series for F.Connect. I'm Heather Piorin, Structural Engineer at WSP USA. Today, I'll be going through the OpenBridge Modeler Training Volume 1 Introduction to Model-Centric Design. In this series of videos, we'll take you step by step through each exercise from the guide. In this session, we will continue going through Chapter 3, including exploring the F.Connect workspace and features. Specific topics covered will be viewing the completed sample bridge and seeing what we're going to create at the end of all of the exercises in the guide. We're going to review the F.tab and the helpful tools. We're also going to explore various features, tools, and settings of OBM. Let's begin. The first thing that we're going to do in this video is take a look at the completed sample bridge. This is a bridge that will be the result of all of the exercises in the guide. As you can see on the right, we have the 3D view of the bridge, and on the left, we have a more classic 2D view. On the 3D view, you can zoom in and out using the click wheel on your mouse, and you can also rotate around. For the rotate feature, we have these crosshairs that you can snap to any point on the bridge, and that'll determine the point that you rotate about. So once that's set to a point, you can use your left click to rotate around that point. So you can zoom in and out and then continue rotating about, for example, the bottom edge of the cap in this case. So as you can see here, we have all of the elements of the bridge modeled. We have the end bent, the piles, wing wall, beams, pedestals. We've got the bearings in there as well. So a nice feature of OBM is that you can turn on and off elements. So if you wanted to take a look at the beams from the top, you could go into the Explorer over here on the left, and you can either dock this Explorer on the right, left, wherever you'd like. Or you can have it be a floating dialog box if you'd like. But within the Explorer, you can go to OpenBridge Model, and this will show you all of the different elements of your bridge model. In our case, we modeled approach slabs as separate bridges, so this is our main bridge here. If you expand all of these, you can see, if you'd like, you can toggle off the deck. And in that case, you can now zoom in and have a better view of the beams. And then if you'd like, you can turn off the beam groups and you can have a better view of the substructure and the bearing pads and the pedestals. So you can control which elements you view by checking and unchecking them in the OpenBridge Model tab of the Explorer here. You can also, like in MicroStation, you can change your display style if you'd like it to look differently. You can kind of play with these and toggle them on and off and see how they look. You can display it however you'd like it to be displayed. And then also similarly to MicroStation, you can use view attributes to turn on and off line styles, line weights, just customize it however you'd like. The information that we're going over in this video can be found in Chapter 3 of the training guide. There are no specific exercises that we're going to be going through. We're just going to explore the different features of OBM.
The next thing that we're going to talk about is the FDOT ribbon. The FDOT ribbon can be accessed from within the OpenBridge Modeler workflow by selecting the FDOT tab up at the top. As a side note, if you would like more space for your design windows, you can double-click any of the tabs and that will minimize the ribbon. Or you can use the Expand and Minimize Ribbon button up here on the right. The FDOT ribbon is a part of the F.Connect Customize workspace, and it essentially replaces the FDOT discipline menu from MicroStation. We're going to go over a few of the F.tools. We already discussed the Create File tool, there's a filters tool that helps you adjust the increments for the annotation on alignments. There's a linked data manager, which we will talk about in a little bit. There are various miscellaneous tools here. There are cell libraries, similarly to what we have in MicroStation, that basically show cells and symbols that are commonly used in FDOT, such as the fib beams, the barriers, the piles, north arrows, things like that. There are ways to search for cells, attach survey reference, report of borings, standards packager from the FDOT standard plans. The rebar tool is very helpful. It is similar to the rebar application from MicroStation, but it has some improvements. You can change the unit or the subunit if you'd like, but you can put in the designation down here, select the bar size, the number of bars, the bar type here, and when you select the bar type, you'll actually get a graphical representation of what that bar type is based on FDOT. You can use a varies dimension if you need to here, and then when you select the bar type, only the applicable variables will pull up here. So you can put in how long the bar is, and once you've filled in all of the applicable variables, the status over here will show as complete. If we do another bar, we can show the use of another type, bar type here. So let's pick 4 for example, and that shows us the closed stirrup here. And when you select bar type 4, the A and G styles for the hooks is displayed. So you can select style 1, 180-degree hook, you can select style 3, 90-degree hook, and then you can put in the dimensions of the bars here. The program will convert feet, inches, and fractions of inches into decimal feet here to be reported. And as you can see, now we're complete, and you can generate a report up here when you're done with your bar list. You can do the takeoff manager to help with quantities based on your model. You can do the QC check, that'll check the compliance for levels used and file names. Explore directories here. If you click current work set, it'll open up in Windows Explorer the work set that you're currently using. There are also various FDOT links to the basis of estimate, design manuals, CAD manuals, standard plans. There are additional web links to different codes, and then you can contact CAD support through this drop-down menu, and you can access the Workspace Doctor and information regarding the program. In order to use the linked data manager, I'm going to go ahead and create a new file. So when I create the new file, rather than using a design file that we're currently in, we're going to use a sheet file. We're going to just select a general notes sheet to create, and you'll see that rather than the 3D seed file that we use for our bridge model, this is going to grab the 2D seed file. And when we create a general notes, you'll see here that the action that is selected when we select that file type is to create a model here. So you'll see that when we create and open this sheet model, or this sheet file here, it's created a general notes view. So that sets up the border here so that we can fill in our information. So with the linked data manager, you can open it up here, and this is similar to and can essentially replace some of the add-ons that we use in MicroStation to connect MicroStation with, say, an Excel spreadsheet to maintain your information. So we'll add a couple in here just as an example. There are templates that are stored within OBM FDOT Connect that you can use. So we will select the general notes sheet as our template, and it's going to want to save that as a text file, so you can save it within your engineering data folder here. So we'll save that text file. You can add a description if you would like, and then click OK. And it's going to have some crosshairs for you to select where you want those general notes to go. So we'll select here. And if you'd like to edit the general notes, as you can see, there's some space to fill in. You can right-click, open source, and it'll open up a notepad for you to edit. So for example, we'll change this to a utility company here. And then we'll make sure you save the file. And then in order to have it be reflected here, you'll have to right-click on the source and select Update Now. And you should see now our text that we just changed in the notepad has been reflected here. That you can also use as a template. You can use a summary box here. So this will be an Excel sheet rather than a text file. This in that same engineering data folder here. And then when you select the template that is an Excel spreadsheet, it will also ask for you to tell it which tab you want. So we'll tell it the worksheet or tab that we want to use within Excel. Once it comes up, there we go. So we'll just go with Bridge 1, and again you can fill in a description if you'd like, and then select OK. And similarly, it'll let you place the, give it a second, and it'll let you place the spreadsheet here. And this is very helpful for when you need to maintain information that might change, such as finished grade elevations or peer variables. So you can maintain them in an Excel spreadsheet, and then you can update them as needed throughout the project. So we'll right-click, open source, and this will open up an Excel spreadsheet. And similarly to the general notes opening up the notepad, we'll be able to edit the content of this table here, and then we'll be able to save it in Excel and close it and update it so that we're able to maintain the information as needed. As you can see here, now we've got the formatted Excel spreadsheet. So we'll save it, close it out, right click, update now. And once it refreshes, we should be able to see the information that we have just entered. Here we go. Test, test, test in our pay item description here. So again, that's a very, very useful and powerful tool to help you maintain information rather than either hard entering it in cells or using different add-ons that existed previously for MicroStation. The last thing that we're going to discuss on this video are the various features, tools, and settings within OpenBridge Modeler. You might notice that there are some tools that are familiar for MicroStation, and there are others that are unique to OBM. The main workflows that we're going to work with are OpenBridge Modeler and Drawing. In the Drawing workflow, you'll see a lot of the tools that you might be used to from MicroStation, such as attach references, models, level manager, and level display, as well as drawing lines, various shapes, move, copy, rotate, array, modify, and groups. I'm not going to go through all of the tools here, but feel free to explore some of the tools on your own. There are different annotation options. There are view options, how you tile your windows. And there are also, these can be located in different workflows. So just because we've got view here in our drawing workflow, it does not mean that we do not have it in another one, because it actually also exists within the OpenBridge Modeler. So there are tools that are located in multiple places. This is Attach tab. We've got Analyze, which has some of the measurement tools that we're used to. There's also a clash detection option here, various curves that you can define if you need to, and then the constraints here are mostly used for creating functional components or parametric cells. This is a more advanced topic that we are hoping to cover in a future advanced training guide. But functional components are basically complex elements that can be modified dynamically with these different constraints built in to react differently to different input. Within the OpenBridge modeler workflow, there's another view tab. There are civil tools in case you need to model horizontal or vertical curves. There's analysis and reporting tools, which again duplicates measure here or some of the placement tools. Utilities help with interoperability here between OpenBridge Modeler and other Bentley products such as LeapBridge Concrete, LeapBridge Steel, RM Bridge, and ProStructures. So you can model a bridge in OpenBridge Modeler, and then you can send it to one of these other analysis programs for analysis, and you can go back and forth. You've got the libraries here that show all the templates, and you can use the built-in templates from F.Connect OBM, or you can also define your own to be used. And then we already discussed the FDOT ribbon here. Like with MicroStation, you can customize your workspace to flow with how you like to work. So you can actually customize all these ribbons to change around what groups are used where, and you can also define different shortcuts. If you have different tools that you like to use, you can create keyboard shortcuts for those. Another feature that you can use up here is a search ribbon. If you were not sure where something was located, you could just type up in here. So say there's a line, but you didn't know where that was. You can search in the search ribbon up here, and then you can scroll and find, okay, I just wanted to place a regular line. And this shows you the 3 different locations that place line are located. So you can either follow this path that it's showing you, or you can just click it, and it'll send you directly to that path. Another thing that is nice, you can, I have the snap down here docked, but if you couldn't find where the snap was located, you can go here to snap mode, and it would bring up this toolbar here, and then you can dock it down there for future use. We already went over the Explorer a little bit when we were going through the model and toggle on and off different elements, but within the OpenBridge standards drop-down, you can also look at the feature definitions here. So within standards, libraries, feature definitions, F.OBM standards and features, you can see all the different F.feature definitions. So within the beams, you could define concrete or steel beams. You can define the different types of barriers, the different types of supports for substructure here. So feature definitions are basically used to control symbology, annotations, and other properties of each element. It defines what the elements actually are. So every time you have an element, you'll have to define a feature definition, and that will help keep those elements grouped. And it also is used during quantity calculations or quantity reports. F.dot, as you can see, has their own feature definitions that are used. We'll discuss feature definitions a little bit more in future exercises. Another setting that is helpful to take a look at, if you go File, down to Settings, File here, and then Design File Settings. This is a similar dialog box to MicroStation, but basically you can set your working units here to anything that you'd like. You can change how the angle is read, the active scale. If you use the proper seed file from F.dot, you should not really need to adjust these too much, but for example, if you were working with finished grade elevations and you wanted to change the working units from feet and inches to decimal feet, then you could do that here. Another option that can be used is to compress the design file. So when an element in OBM is deleted, it is no longer displayed, but the program still has a record of it, and this is how the undo buffer is maintained. At the end of a session, you can set the program to compress the file on exit. That way you can reduce the file size. You can also compress the file while you are working in it by using this compress button up here, but just be aware that if you do compress the file in order to reduce the file size, you will lose that undo option. So it's best to just use the setting, File, Settings, User, Preferences, and then under Operation here, you can have the option to compress the file on exit. You can select that, and that way it'll help manage your file size. Now OBM saves files automatically in terms of content, so in the case of a crash or a power failure, you won't lose your work. It's constantly saving. However, file settings are not saved automatically, such as active color or the view setup, but you can manually go through and save those settings by going to File and Save Settings. Thank you for joining me today for the CAD Office series for F.Connect. This was a continuation of Chapter 3 for the OBM Intro to Model-Centric Design Guide. In the next video, we'll go through Exercise 4.1, incorporating roadway and survey data into our OBM file.